Kubernetes has completely transformed the way to manage and deploy large-scale applications. It's one of the most important tools in modern DevOps, and if you ever wondered how it works or why so many companies rely on it, I wanna say that this video is for you. I'm Raslan, 23 years old junior software engineer, and today I'm going to break it all down for you in a simple and practical way, even if you are just starting out. So go ahead, grab a coffee, pen, and a paper, and let's get started. Let me tell you a quick history of Kubernetes. Kubernetes is an open source project created by Google. Its main purpose is to manage and orchestrate containers. What that really means is that Kubernetes helps you manage your application inside containers in any environment, no matter where they are running. So instead of manually managing each container, Kubernetes takes care of it automatically. What problem did Kubernetes solve? When DevOps team first started using containers, things worked completely fine, but as the number of containers grew, managing them became a disaster, which led to create an infernal environment for developers, because we had multiple environments, multiple operations, multiple applications, and way too many containers to track. It became nearly impossible to manage everything manually. That's when people realized we need a tool that can coordinate and manage this complexity, and that's exactly where Kubernetes came in. I know that you're asking now behind the screen why Kubernetes is so important in the DevOps lifecycle. So let me tell you that Kubernetes played a major role in the DevOps lifecycle for a few key reasons. First, we have the high availability. Your application is always up and running, no downtime at all. Second, we have scalability. You can easily grow your app as needed without complex configuration. And on third, we have efficient resource usage. Kubernetes automatically distributes workloads across your machine. Did this architecture scare you from the first sight? Don't be afraid, it's simple and easy. In any Kubernetes cluster, you have two main types of nodes, master node and worker node. Each node runs a process called kubelet, which is what allows it to communicate with the rest of the cluster. Your application runs inside of the worker node, and each one holds multiple containers. The master node is the control center, and it runs several important components. We have four components of the master node. First, API server, the entry point of all the requests of the cluster, the entry point for all the requests to the cluster, whether you are using the Kubernetes dashboard, command line tool, or APIs. Second, we have controller manager. It monitors the cluster and performs automated tasks like restarting containers if they crash. In the third place, we have the scheduler. Decides where to run each container based on available resource and of course your configurations. And now we have the etcd or the etcd, a key value database that stores the entire state of the cluster, including all the configuration and the current status. On the fifth place, we have the virtual network. Connects all the nodes in the cluster so they can talk to each other smoothly. Here we have the core concepts you should know. What is pods? In Kubernetes, the smallest unit in work, which is called a pod. A pod can contain one or more containers that runs together. Each pod gets an internal IP address, making it act like a mini server. When we configure application in Kubernetes, we don't interact directly with containers. We work with pods. Okay, some of you will say, what happens if a pod crashes? If a pod is destroyed or terminated, Kubernetes will restart it automatically. But here's the issue. The new pod gets a new IP address. So here, the servers in Kubernetes solve the problem. It gives the pod a stable, permanent access point, even if the pod's IP changes, so other applications can always find and connect to the pod through the service. I'm gonna teach you how to read the Kubernetes configuration file code. So everything you want to deploy in Kubernetes need to be defined in a configuration file. These files are sent to the API server on the master node, and they must be written in a format that Kubernetes understands, usually YAML or JSON. So first of all, we have the key named kind, and the value is deployment, and that says that this YAML file is responsible for creating the pod. And then we have this key called replicas, and its value is 3. And here we tell the Kubernetes that we want to create 3 pods from our application which have the name example -app. We are going to do the pod from this image, which is example image latest, which is the image name that we are going to use. And the communication will happen on port 80. I hope this helped you understand Kubernetes better. If you liked the video, please like and subscribe, because in the next video, I'll explain Docker and containers. Also, there is a quiz link in the description. Drop your answer in the comments below, and I'll be checking them and seeing who really understood Kubernetes and who did not. If you have any questions or topics you want me to cover, drop them in the comments down below. Further than that, peace and see you next time.